Hi, myself Keshav of CSC Data Science, and today our subject is Basic Electrical Engineering. In that, we are going to now today discuss about KVL and its applications, and the contents are introduction, voltage division in series circuit, current division in parallel circuit, Kirchhoff laws. Now we are gonna start from basic introduction like current gets divided in different path when resistance are connected in parallel, hence current division is applicable in parallel circuit. The voltage gets divided in series but current remains same, hence voltage division is applicable in series circuit. Currents and voltages follow KVL and KCL laws in circuits at junction points, nodes and in loops. Complex electrical circuits with multiple loops can be solved with mesh analysis. Current voltage division finds application in construction of electric meters and sensor devices. Here we are displaying some pictures of digital meters and sensor devices. Voltage division is used in reducing voltage level to lower the value of voltage divider. A 200 kilovolt voltage divider with ratio 10,000 is to 1. A 600 kV high voltage capacitive voltage divider is shown below. Resistive voltage dividers are used for measurements of lightning impulses and other large impulses voltages. Voltage division concept is used to making a rheostat potentiometers. The rheostats are given below. Voltage division concept is used in making radios, amplifiers and electric devices for adjusting signal levels. Principle of voltage division and current division is used in potential transformers and current transformers for stepping down high voltage and high current in power plants. And now we are going to discuss about current division. The total current gets divided in parallel circuit while the voltage across each element is the same. The current division rule can be understood by considering a parallel circuit shown below and the small circuit. Current division. Here there are some formulas like I1 is equal to IR2 by R1 plus R2. I2 is equal to IR1 by R1 plus R2. Here I1, I2 are total current I is shared by the resistors in inverse proportion to the resistances. This is known as principle of current division. Here R is known as resistance. In the terms of conductances, we have I1 is equal to Ig1 plus by G1 plus G2. I2 is equal to Ig2 by G1 plus G2. And now we are going to discuss about Kirchhoff's laws. Kirchhoff's laws are two equalities that deal with current and voltage in electrical circuits. They are first described in 1845 by German physicist Gustav Kirchhoff. Kirchhoff laws. Ohm's law by itself is not sufficient to analyze circuits. When it coupled with Kirchhoff laws, we have sufficient powerful set of tools for analyzing a large variety of electric circuits. Kirchhoff's current law is based on the law of conservation of charge. Kirchhoff's voltage law is based on law of conservation of energy. Kirchhoff laws can be applied on AC circuits in the same way as for DC circuits, provided we use phasor sums rather than algebraic sums. And now we are going to discuss about Kirchhoff current law KCL. Kirchhoff current law KCL states that algebraic sum of circuits entering a node or a closed boundary is zero. The figure below shows that currents are entering and leaving node A. Here the currents are entering A are I1, I3, I4 and the currents leaving node A are I2, I5. Before applying KCL sign convention is very important. The following sign convention is used. The current entering node is the sign convention is used as negative. The current leaving node, the sign convention is positive. Applying Kirchhoff current law with sign convention 1 has minus I1 plus I2 minus I3 minus I4 plus I5 is equal to 0. Now Kirchhoff current law. I1 plus I2 plus I3 is equal to I2 plus I5. Alternatively, Kirchhoff's current law is also stated as the sum of currents entering a node is equal to sum of currents leaving the node. And now we are going to discuss about applications of Kirchhoff's current law. In practical, application of KCL is to determine the amount of current flowing through individual electronic component in a circuit. Using that law, we can manipulate the current to the component by controlling resistance to it. The KCL states that for the balanced network, the current coming at the node is equal to current outgoing. So, on a simple note, we can balance a given circuit by adjusting the voltage and current so that at the selected node, the current if measured is 0 because incoming current is equal to outgoing current. So, by balancing, we can calculate a number of parameters from circuit. The potential application of KCL is to determine the amount of current flowing through individual electronic component in the circuit. Using that law, we can manipulate current to component by controlling resistance to it. Kirchhoff law states that algebraic sum of flow of current into and out of node must be equal. The KCL states that for a balanced network, the current coming at a node is equal to current outgoing. So, on a simple note, we can have balance in a given circuit by adjusting voltage and current so that at a selected node. This is true for all DC circuits and AC circuits at frequencies where the wavelengths of electromagnetic radiation are very large compared to the circuits the law is valid. And oh, Kirchhoff's current law states that applying Kirchhoff's current law with sign convention, practical application of KCL is to determine the amount of current flowing through the individual electronic component in a circuit. Kirchhoff's first law, which is known as the Kirchhoff current rule, clearly states that the amount of change entering the node current incoming is equivalent to the value of amount of charge exiting the same node or current outgoing when many branches of conductors meeting at a particular node. The total sum of charge or current around the node is zero. Generally, a sign convention is maintained throughout a circuit analysis. The current entering a particular node is considered as positive while one leaving is considered as negative. Kirchhoff laws have plenty of applications, but it has also many limitations and disadvantages. To start with, many complex circuits require detailed analysis. Kirchhoff laws help to simplify these circuits and calculate unknown currents and voltage more effectively. These laws can be used in analysis of any electrical circuit practically, but there are pros and cons to everything. Similarly, Kirchhoff's law also various limitations and disadvantages. The measure that closed loop has no magnetic field in it, which is fluctuating. Induction of EMF or any electric fields is possible in the circuit. This will eventually cause the current and voltage rule to fail. High frequency circuits are also affected by KCL. Another issue is only electric charge is constant inside the circuit. KCL is valid and applicable. Thank you.